everybody, when you come to class tomorrow, we are going to be starting a lab called Copper Recycling Lab, which is going to take a source of copper penny, that is not pure, and taking it through a series of reactions to make it pure. Our source is this penny. It's an old penny, 1977, which means that it's about 95% pure copper. So we should get most of this penny back again when we go through our series of reactions. The first step of this reaction is to react the copper penny with nitric acid. Now, this reaction was first recognized or talked about in a journal by Ira Remsen. He was an apothecary, that's kind of like a pharmacist, in England back in the 1800s. And he saw a reference in a journal about nitric acid acts on copper, and he wondered what that meant. Now, he actually did this just on the countertop, and we're going to discover why that was not a great idea to do. So I've got this whole little setup here. We're going to actually drop our penny into the flask. I'm going to get my goggles on because we're working with nitric acid.
Why do you not immediately put it straight into the graduated cylinder?
Because the reaction itself is going to take place in the flask, and the graduated cylinder is just here to collect the waste. There is going to be a gas produced that is not safe to breathe. And because I'm not doing this in the fume hood, we need somewhere for those vapors to go. And as the vapors are produced, they will bubble into the water. My wonderful assistant has already added some sodium hydroxide to this flask, which will neutralize the poisonous gas that we're going to create.
Okay, awesome.
Okay, goggles on, nitric acid. By the way, it says here, hazard alert, extremely corrosive liquid. He didn't know that about nitric acid, so he didn't realize that he needed to be careful. There we go. So I'm going to dump some over and very quickly put the little cap back on, and then we'll see what's happening.
Okay, awesome.
Okay. So I don't know if you can come a little closer and take a look at what's happening here.
So why is it turning green?
So the copper in the penny is being ionized. Some of the electrons are being pulled off.
Ooh. Okay.
And when electrons are pulled off of copper, it turns green. Copper 1 ions are green. Okay, I've got a hold of this so that you
Okay.
continue your process. So you'll see this lovely brown gas that's being produced here, orangish brown. That is the chemical, the gas that we're trying to neutralize.
Okay.
When Ira Remsen did this, he did it just on the countertop, put the penny down, dumped some nitric acid over it, and it started producing this awful toxic gas. And he started choking and gagging and realized he probably should not stay in the room with the toxic gas.
Yeah.
So he had an open window, he decided to pick up the penny and throw it out the window. In the process, he discovered that the nitric acid also acts on...
Oh, okay.
We're gonna you are seeing the same thing I'm seeing. Some of that
Yeah,
gas
so...
is not...
Yeah, why isn't all of the gas going straight into it?
That is a very good question. We are gonna make sure you are not too close.
Yeah, okay.
And
Do we need to stabilize this?
maybe figure out a way to
Okay.
stabilize it a little more. There we go.
Technical difficulties.
Technical difficulties. So when Ira Remsen picked up the penny and threw it out the window, he discovered that nitric acid also acts on fingers. It severely burned his fingers. Now, what would you do if you got nitric acid on your fingers?
I'd run and go wash it off immediately. Yeah.
That would be so smart. That's not what Ira Remsen did. He wiped it on his pants
Oh.
and discovered that nitric acid also acts on pants. He said it was his most expensive experiment ever, that it actually destroyed the pants. He had to get some treatment, medical treatment for his skin. It was not a good situation.
So does it just go through everything?
It does. Nitric acid is pretty nasty stuff. Not glass, which is why we're doing it in glass.
Thankfully.
Now, I don't know if you've noticed, but this is really hot.
Why is it getting hot?
So the reaction between the nitric acid and the copper is exothermic. We've talked about that idea already. When bonds form, they release energy. And so it's in that process of forming bonds between the copper ions and the nitrate ions that we release energy in the process.
Okay.
Now, this is slowing down quite a bit, and you can start to see a color change happening over here.
Yeah.
That tells me that even though there is some gas escaping, which is not good, most of it is getting into the water, and the water is neutralizing it. So that's encouraging.
Yeah. Yeah, so is that why it's starting to turn clear?
Right. That's evidence of it being neutralized.
Okay.
Now,
I feel bad that my stand didn't work.
that's okay. We're doing just fine.
Okay.
Now, as this slows down, there will be something else we see. For those of you watching at home, I'm going to speed up this section, or you can fast forward through this section for a little bit so you don't have to watch the whole thing in slow-mo. We'll just keep filming.
Okay.
Almost done.
I honestly forgot how long this part takes.
Well, because you guys didn't watch the whole thing.
Oh yeah, we did it overnight.
Yep. Okay. Looks like we're pretty much done. Last couple bubbles there. Nope. And then we'll start to see eventually.
So is the rest of the pink in there just caused by excess?
Yes.
Okay.
Okay. I think it's starting to, oh. So in a minute, I'm going to have you zoom in on the water level there.
Okay. Right at the end?
Yep. And you're seeing that now, instead of gas being pushed into the water, some of that water is being sucked up the tube. That's because the reaction is done and the flask is releasing its excess heat to the surroundings and cooling down. We're going to discover in a later unit that as gases cool, they shrink. And so as it's shrinking, it's sucking up the liquid. And there's one more really cool part to this. Once the water enters our flask. Almost.
Taking a second.
Getting close. And the water is starting to go in. Uh-oh.
Oh.
Not quite enough water. But you can see what has happened, that we no longer have the green color. We actually have a blue color.
So why did it turn blue?
So that means we've gone from copper 1 ions to copper 2 ions. So the addition of water actually stole another electron from each of our coppers and turned our copper blue.
Okay.
That's where our demo is going to end. Tomorrow, you are going to get a sample of the copper sulfate here, or the copper nitrate here, and you will have to get the copper back again. Have
Awesome.
fun.